Welcome back to All10's video series on asset liability management. This video demonstrates problem-solving techniques when answering questions associated with the content from Chapter 4, Interest Rates, from the whole text, Options, Futures, and Other Derivatives. Past CAS exam questions are solved to illustrate key concepts from this chapter, which include calculating the present value of a forward rate agreement, and calculating the payoff to a company that has entered into a forward rate agreement. Questions covered in this video include question 27 from the 2001 exam and question 10 from the 2007 exam. In question 27 from the 2001 exam, we're asked to answer the following based on Hull, Options, Futures, and Other Derivatives. A. Briefly describe a forward rate agreement. And B, given the following information, the 2-year zero coupon interest rate compounded continuously, and the 3-year zero coupon interest rate compounded continuously, and that you enter into an FRA where you receive 10% with annual compounding on a principal of $2 million between the end of year 2 and year 3. What is the present value of the FRA? Show all work. A brief description of an FRA is: it is a forward contract to pay a specified interest rate on a given principal at a specified future period. In Part B, we're asked, what is the present value of the FRA? Step 1. Write an equation to determine the present value of the FRA. The value of the FRA promising that RK will be paid rather than received is V is equal to L times R sub F minus R sub K times T sub 3 minus T sub 2 times e to the negative R sub 3 T sub 3, where R sub K is the rate of interest agreed to in the FRA, R sub F is the forward LIBOR interest rate received between T1 and T2, calculated today, and L is the principal underlying the contract. Step 2. Determine the value of R sub K, the rate of interest agreed to in the FRA that will be earned between time 2 and time 3. Recall that we were given that the 2-year zero coupon interest rate is 7.5% compounded continuously, and that the 3-year zero coupon interest rate is 8% compounded continuously, and therefore R sub K is equal to e to the 0.08 times 3 divided by e to the 0.075 times 2 minus 1, and therefore R sub K is equal to 0.0942. And in step 3, using the equation in step 1, the result from step 2, and the given information, compute the present value of the forward rate agreement. Recall that L was given to us as 2 million and that R sub F is equal to 10%, and therefore V is equal to 2 million times 0.10 minus 0.0942 times 3 minus 2 times e to the negative 0.08 times 3, and that is equal to 9,124.88. In question 10 from the 2007 exam, Company X has entered into a forward rate agreement with Company Y with a principal amount of $2,000 at an interest rate of 5%. The agreement is for 6 months, incepting 1/1/2007. The forward LIBOR interest rate between 1/1/2007 and 7/1/2007 is 5.2%. The actual LIBOR interest rate observed in the market at 1/1/2007 for the period 1/1/2007 to 7/1/2007 is 4.8%. In Part A, we're asked to calculate the payoff to Company X, and in Part B, we're asked to calculate the value of the FRA assuming continuous compounding. Some comments before solving this problem. A forward rate agreement is one in which a certain interest rate applies to either borrowing or lending during a specified future time period. It is assumed that the borrowing or lending will be done at LIBOR. Consider a forward rate agreement where a Company X is agreeing to lend money to Company Y for the period of time between T1 and T2. Define R sub k as the rate of interest agreed to in the FRA, R sub f as the forward LIBOR interest rate between time 1 and 2 calculated today, R sub m the actual LIBOR interest rate observed in the market at time 1 for the period between time 1 and time 2, and L the principal underlying the contract. Company X will receive interest on the principal between T1 and T2 at the fixed rate of R sub k and pay interest at the realized market rate of R sub m. Company Y will pay interest on the principal between T1 and T2 at the fixed rate of R sub k and receive interest at R sub m. Usually, FRAs are settled at time 1 rather than time 2, and that's why the payoff must be discounted from time 2 to time 1. For Company X, the time 1 payoff is L times R sub k minus R sub m times T sub 2 minus T sub 1, all divided by 1 plus R sub m times T sub 2 minus T sub 1. Again, Part A asks us to calculate the payoff to Company X. Using the equation shown here, and given the data in the problem, compute the payoff to Company X. Recall that we were given the loan amount of $2,000, R sub k equal to 5%, R sub m equal to 4.8%, R sub f equal to 5.2%, T sub 1 equal to 0, and T sub 2 equal to 0.5. And therefore, the payoff is equal to 2,000 times 0.05 minus 0.048 times 0.5 minus 0, all divided by 1 plus 0.048 times 0.5 minus 0. And that is equal to 1.95. In Part B, we're asked to calculate the value of the FRA assuming continuous compounding. The value of an FRA promising that R sub k will be paid rather than received is V is equal to L times R sub f minus R sub k times T sub 2 minus T sub 1 times e to the negative R2t. Step 2. Using the equation in Step 1 and the given information, compute the present value of the FRA. Note that we're given all the values in the problem with the exception of R sub 2. In general, R sub m is equal to the continuously compounded zero rate, and that is equal to m times the ln of 1 plus R sub m divided by m. In this situation, m is 2, R sub m is equal to 0.048, and so R sub 2 is equal to 2 times the ln of 1 plus 0.048 divided by 2, which is equal to 0.0474. And therefore V is equal to 2,000 times 0.052 minus 0.050 times 0.5 minus 0 times e to the negative 0.0474 times 0.5, and that is equal to 1.953.